Hi guys, welcome. I'm Chris from AUDAC and welcome to another webinar of NetGear Level 2.
Yeah.
It will take approximately about 45 minutes, max 1 hour. As usual, as you know, we have our colleagues in the chat box to support on any questions that might pop up during this webinar. For you who have the video in front of the presentation, you can dock it to the right of your screen in the menu option. And again, I would like to welcome Erik Lindeman from NetGear, who will give this level 2 presentation. In the chat box, I would like to suggest that we keep the questions related to the webinar so that we do not drift off too much. So, Erik.
Yeah, thank you, Chris. Welcome everybody to the webinar, the phase 2 webinar, where we go a little bit in the technical depth of the NetGear proposition. I think there are some people who in the webinar were already joined the webinar. But first, I like to give a little refreshment, a very small refreshment of a couple of slides of the proposition of the NetGear M4250 series of switches. What you see, we have switches we were designed for AV, not only internally with the software, but also with the hardware. And of course, the support we offer to help you with the projects. And most of the time, the switches are used because, on the in the rack, and you can mount them face to the front, and all the plugs, all the connections you can do on the back of the switch. So it gives you a little bit of extra security and a better view. For the M4050 lineup, we have the 1 gigabit switches. The edge of the switches are 1 gigabit. There are also a couple of switches that have a 10 gigabit uplink. So if you need more performance, especially for AV applications, where the demand of the bandwidth between the switches is key to have a good and stable transmission of your signals. And we also have some 10 gigabit switches for distribution, as Sergio explained last week in the webinar. When you have questions on this, we can go off topic later on, and you can ask your questions in the chat about it. Another thing is the PoE demand of the equipment used for AV. During the time, a lot of AV manufacturers decided that PoE is also good enough to power their devices. So we have a rather huge variety of switches of PoE budgets and that kind of things in our switches. For small applications, we have a low power PoE budget. And for the demanding, like the amplifiers, you see on the left of your screen, left down, we have a switch that's capable of doing 90 watt per port. So the amplifier can strap for its full power and can be fed by the switch. So no electric wires anymore.
Erik, if I can pick in on that one,
Yeah.
There was a previous webinar on the level 1, actually a good question that popped up.
Yeah.
Regarding that PoE power, what about cable length? So if you have a high power demand device, so if I hook it up with, let's say, 100 meter cat cable, what about the power loss over the cable? How is that calculated? I know there are PoE calculators for that, correct?
Yeah, there's a PoE, but you don't have to calculate it, because when you stick to the certified cabling, Cat6A by example, and when you keep to the norm, you will have enough power at the end of the cable of 100 meters. So the loss will be 5%, but the switch is also compensating the loss by knowing the cable length and power up the wattage of the cable a little bit with a little bit of correction. So as long as you keep to the cable length, 100 meters is the max for a workable power at the end.
Okay, great. Thanks.
Okay, welcome. So let's go where we come from. The technical part of the webinar. To install NetGear switches, you need a certain kind of knowledge, but I can assure you the knowledge will be very minimal because we take care of a lot of things in our AV menus. So what you can see at the configuration basic, what you need to install a NetGear switch, you need to be aware of what an IP address is and a subnet mask. Does it sound familiar? Okay. What is a DHCP server and what is DHCP and how it's working? You have to know what the default gateway is. The default gateway is the endpoint of your network where the router takes care of the rest of the packets. It's outside of your network. You need to know what DNS is. That's for name resolving. So by the way, netgear.com or audac.com, where the network name is resolved in an IP address. And for your convenience, we're using names instead of numbers because names are much better to remember. You have to know what a VLAN is, the principle of a VLAN. And normally you need a great knowledge about multicast settings, that kind of thing. And that's the thing we take out of the, we provide you with the AV menus. So let's go a little bit further. The AV menu looks like this. It's a profile-driven menu structure where you can configure your ports. And later in this webinar, I will show you how you can configure those Dante audio VLANs and video VLANs, and in a very easy way, which is not conflicting with other settings. So the configuration basics. What is the behavior of IP multicast network traffic? In fact, IP multicast is a system where IGP traffic, Internet Group Management Protocol traffic, is gathered by a sort of a database and handle the traffic between the ports and start blocking the ports where the signal is not needed. So let me show this by an example. If you take a good old NetGear switch out of the box and you connect your devices and you start to send the signal to a device, if you don't configure anything on that switch, all your ports will be saturated with the traffic of the IGMP source. To avoid this, you have to configure the switch. So it's no plug and play. So you have to configure IGMP snooping, IGMP query. That's a kind of a database. IGMP fast leave. So the signal can be switched on and off very easy. If you want to withdraw a loudspeaker or an amplifier, or add an amplifier, and the other equipment don't have any use. And there must be also a setting for drop and reset multicast flooding. So all the packets not belonging to a port must be dropped and not sent to the port itself, because in this case, when there is traffic on those ports, by example by the control panel, the network interface receives those packets and he's come to a conclusion, oh, there's nothing with this is not for me, so we have to drop the packet. But that will cost you resources of the equipment. So if the switch is filtering all that traffic, the devices won't get the unsolicited traffic and will be run seamlessly with no pain. But you have to do some settings, basic IGMP settings. If you take a NetGear M4250 series out of the box, you can plug in the power, you can plug in your devices, and you're off to go. That's how simple it is with ProAV with NetGear. But what would you do if you have multiple switches? And what are the considerations about the bandwidth? So let's take this example. You see here two old-fashioned NetGear switches. You see two cables between the switches. And what spanning tree will do is automatically block the traffic, block the cable, block the ports from the redundant cable here. And this is because Ethernet is no ring protocol and no ring topology. So there will be a loop, and Ethernet can't handle the loop. So you have to configure LSP of trunking to the ports. You have to do all the other settings, the snooping, the query admin mode, and that kind of thing, because you have two switches now, and one of the switches must be the IGP query, and the other switches you can't have two captains on a chip, so you need to disable IGP query on the other switch. You have to configure IGP fast leave, etc., etc., and by then you get a normal working solution for basic IVRP. The other thing is quality of services, but that is handled also in our switch with the templates. So when you look at two switches on the 4250 series, you buy a piece of cable from 10 gigabit, you buy some SFP modules, SFP plus modules, connect it all together, and then it's still working out of the box. So you don't have to configure anything on the fiber optics. You can add your source and you can add your display on the other switch, and off the fly it will work standard, no problem. The traffic between the switch in the case of this video with low compression is about 800 megabits per second. So the 10 gigabit cable is good enough to withhold all the traffic from the 1 gigabit source to the display. Even when you add another display, the IGP signal will be the same. It will be a multicast, so there's only 1 times 1 gigabit between the two switches. When you add another device, also from 1 gigabit or a little bit less, you still have enough bandwidth to handle the traffic of 2 gigabits to one switch to the other. And this is all plug and play because the IGP Plus functionality is default enabled on VLAN 1 of the switch. So out of the box it will work. But what if I change the 10 gigabit speed for a 1 gigabit cable? So in this case, with all the transmitters and the use case of 2 gigabits, 1 gigabit will not be sufficient enough to handle all the traffic. So at the end, no signals will go to the display. You can add another cable with LSP, also without any form of configuration between the switches, and now you have to double the bandwidth to 2 gigabits, and that's still enough to handle both streams. And this is again a working situation out of the box with no problems at all. And this is because NETGEAR also supports auto LSP, and auto LSP will discover, okay, the cable you connected extra is no loop, but it will be an LSP trunk, and it configures it under the hood, and it works out of the box. Okay, are there any questions already about this, Chris?
Seems all clear to me.
Okay. And for everybody? Okay, let's go on. What about multicast and multiple VLANs? Because don't you have to be an expert to configure VLANs on switches? And what will you do if you don't have any experience at all? Now, that's quite simple. We have a system, a special AV menu, and when you address that menu, you can configure by profile all the IGP switching settings. So what you now see nowadays, most of the time, left you see a normal ICT environment, and left you have your audio video environment or your audio environment, and you can couple the switch, of course, to the ICT network. So far so good. And you can start configuring your switch. So I take the port 1 on the switch, I configured for VLAN 1. So what I have is an IP range described on the left of the screen. 192.2.0. I live behind the 192.168. I log into the switch, and by the way, the switch has received an IP number already from the DHCP server of the ICT network. Here you can see all the ports, and if you scroll a little bit down, show legends, I can also get more information, and I scroll down, I can adjust the fan mode. Now it's sent to off, but out of the box it will be in quiet mode. And I can send the fan mode to off, and then the fans are silencing out as long as the temperature is below 27 degrees Celsius. So when I look a little bit further, you can also adjust the IP address and all other kind of settings. So for this one, VLAN 1 is well configured. And now we're going to configure an AV over IP network. Now we give it an IP range 10.10.20. So first I go to the profile and I see its video. So when I click here, then I can choose the ports I want to use and give the profile a name. By this example, I name it AV over IP. I choose the ports. Port 1 was for the ICT network, so I go from port 2 to port 20. I select all the ports until all ports are tagged for the configuration. I give it a VLAN ID. Every VLAN has a number, so I give this number 20. I decide to take the color red for AV, so I click the red color, and then I'm able to enable VLAN routing, and I can give the new VLAN an IP address, and it must be the IP address of the switch. So I give it 10.10.20.1. I adjust the subnet mask with 2.5, 255, 255.0. And I decide to have a DHCP server just because it can. Sometimes the controllers will provide DHCP, but if you don't have any DHCP provider, you can use the switch also for DHCP. With the DHCP server, I'm also configuring a DNS server for name resolving. And when that's done, I can click on save, and then you see all the ports are configured. And this is about all the VLAN knowledge you need to have, except for one little thing I will go onto in the next slide. And this is the same situation. You see my configured ports. You see the switch is hooked up on the network. So the router has 192.168.2.1. The switch is on the same subnet with 192.168.245. And this is the default gateway for the switch, and this is the default gateway for VLAN 1. So when I start a search on the internet, by example, and the packets go to the switch will hand it over to the router will hand over the packets to the internet will give the answer back, and then it arrives on the router again. But here comes the little caveat. The router doesn't understand your new defined 10.10.20 network because he's not informed about it. So what you can do is inform the router by adding the router table and tell the router all traffic from VLAN 20 IP address of IP range 10.10.20.0 is known by the IP address of the switch 192.168.2.2.45. So when you configure this static rule into the switch or use a dynamic routing protocol, your router knows the way to the switch and can hand over the packet to the switch, and the switch will retransmit it to VLAN 20. So that's all about statical VLAN routing. And if you have this basic knowledge, you can configure a complete AV environment on whatever we have on certified solutions. Are there questions on this?
What about the profiles, let's say for AUDAC? Where can they be implemented? Is it the same where you showed us the AV?
This is the same interface. And if you go a little, I can go back to the slides maybe. Let's have a look. Go to Dante. You don't see. You see the top profile in the slide. It's on the profile template, especially for Dante audio. So if you have an AUDAC speaker or an AUDAC device, audio device, you can also click this profile, add some ports like this. This page is displaying for Dante audio, and give also the same IP range for that kind of equipment. And when you need a DHCP server on this, you can also configure it.
Okay, thanks, Eric.
Is this clear? Clear enough for everybody? Okay. Let's jump to the rest of the slides. That's the point. What do I ask an IT administrator when I want to hook up my network? And that's also quite simple. You need to have the connection to his network, and you need to free one port of you for you, gives you a 0.1 port on their switches for you. You need to have a static VLAN route to the newly switch you are going to configure on his VLAN, on his LAN. And when he's concerned about security, he has to adjust the kind of rules on his switches called ACLs, access control list, for security. And in an access control list, it's a little bit like a firewall rule. So the administrator of the network can decide, okay, what equipment on the newly VLAN has access to my normal network or have access only to the internet. And when they want to integrate the situation, they can also grant the AUDAC IP numbers for the control panels and for the switches also to their normal network, so they can remotely or on the other segment control the Dante audio network. And that's about it. And what about support, of course? When you have questions, you can address the pre-sale support of PVS on email address support@pvs.global. And you can also, when multiple disciplines are going to be involved, except for AUDAC, or maybe you have some other brand of video you want to use together with the AUDAC, you can also consult us and ask our opinion or help with the design of a network. This kind of jobs is done by the dedicated IV over IP design team, and I'm also a member of it. We can give you pre-sale support, of course, second opinions, network designs, and we can help you with the deal registration and that kind of things. That's the part for pre-sales. There's also an extra way to educate yourself. So when you're an AV integrator, you can go free of charge to the NETGEAR Academy, do the courses, and get your certification online. It's all free of charge. And also AUDAC as a completely educational site. It's also educational videos. Maybe Chris, you can tell something more on this.
Yes, we offer on the education platform, of course, multiple videos about training of our products, how to use them and how to configure them. We also do the webinars on our products. And of course, the main source to consult any technical issues or more information, we have the portal for our customers that they can log in and find on the product page under the support section multiple Q&As and support tips. So that's the first thing that should be checked if you run into any issues or questions about products. You can find it on the portal. we have some questions popping up, Eric.
Okay, great.
So ACL, the access control list, and RIP. Maybe you can give me some information on that one.
The first one is the second one. Let me have a look. Okay. What is the meaning of an access control list? An access control list is a filter. What an access control list does is on a port or on a VLAN is filtering the traffic and tell what is restricted. And if there aren't any restrictions, the traffic will go through the port and won't be blocked. A kind of example is when you have an access point, you have a gas network, and you have a normal office network, but you want to have the gas access to your printer. You can set normally the traffic between the gas traffic is only going straight forward to the internet. But what you can do with an access list is add an exception that your guests are able to use your printer, and that you can define in an access control list. And all managed switches are using access control lists. Dus not the entry level and the mid-range switches, but the switches with the CLI interface, and the more high-end graphical switch with the graphical interfaces will have an access, can handle every access control list. In practice, you see access control lists most of the time in the larger deployments with the bigger buildings, and not on the small scale, but on the medium to high scale, you find access control lists. Okay. Is that answering your question, Sloopdan?
And also RIP, okay. Eric.
Yeah, RIP. It's not rest. This is not rest in peace, but that is it's a RIP protocol. How you call it? A router information protocol. RIP. You have RIP. You have OSPF. You have certain other protocols, and what these protocols are doing is they are configuring on an automatic way the routes between VLANs or network segments. And router information protocol is the way on small scale networks, the routers or the routing switches are exchanging information to the paths on the network, so the traffic can flow from the one segment to another segment via switch A, B, or C, and ending at another VLAN with another IP rates. So you have RIP, router information, and you mostly use on larger network is OSPF. It's called Open Short Path First, and that's a more lean and mean information protocol. It's not. It's more multicast related, and RIP is more broadcast related, as I can take it down to AV levels. Okay. Does it help the answer?
Yes, thanks, Eric.
Okay. Are there any other questions? Okay, we go to the next slide. So what we combine with NETGEAR and the Pro AV proposition we have now is to give you on the software side of the configuration and that kind of thing. We give you a lot of help with the special interfaces. And by pre-configuring our switches on VLAN 1 for AV, it's almost plug and play. And when you need the extra VLANs or the extra profiles, it's simple to click a profile and avoid conflicting situations because it's already found out in our labs. On the hardware, we're looking at the proposition of the switches, where they are going to be installed in racks in visible locations. So we take care of the design Of course, we take care of the performance because every port is line rate between the switches, and some switches have the higher capacity uplinks, and all switches will have PoE with all kind of power levels built into the switches, so you can choose the right switch with the right PoE budget for your situation. And we have the support part, level 1, level 2, development, all that kind of stages are involved with NETGEAR Pro AV. So when you call somebody from pre-sales or after sales, everybody knows where he's talking about. And you have the training and certification sites where you can educate yourself and certificate yourself, of course, on the AV topics. Okay? And this was the last slide.
Okay, thanks, Eric. I think we covered most of it in this level 2 presentations. We have a question. Can you tell us a few words about differences between broadcast and multicast? For some people, that's not very clear. So exactly what the difference is and when to use it, for example.
Yeah, in fact, in basic, a broadcast and a multicast is the same principle. A broadcast is a transmission to multiple clients, but the big difference between broadcast and multicast is that the broadcast will go to every device. So when you have a DHCP request when you switch or your audio device want the DHCP number and he's asking for a DHCP number to the DHCP server, it will be broadcast and every device will receive the broadcast. No matter what. As long as it's on the same level, on layer 2 of the network, the device will receive the broadcast, the DHCP server also will receive the broadcast and give the device an IP number. And that's all about broadcast. If you have a multicast, it's the same principle, but you can solicit for the broadcast. So when you have a signal, a transmission, by the way, just as you are in your car and you want to use to a radio and select a frequency, you can tune in on that frequency, and all other radios tuned to other frequencies will ignore the signal. So what will happen with a multicast is there is a source. When you want to use the source, you can address the source and request for the multicast, and the multicast will only go to the selected to the terminals who solicit for the stream. And that's in principle the big difference between broadcast and multicast. And when there is also need for another webinar based on more on multicast, broadcast, and that kind of expertise, we can also organize an extra webinar for this together with Chris to have all that kind of topics also addressed.
Okay, great. Thanks, Eric. I think it's also worth mentioning, like AUDAC Touch, when it uses in a configuration that you have multiple VLANs, that it's important that those VLANs, of course, can talk to each other. So in case in AUDAC Touch you want to manually add a device that's in another VLAN, that's also possible to control that device, but it will, for example, not show up in the discovery page. So that's why you need to configure those different VLANs so they can talk to each other.
Yeah, because the discovery is also done by broadcast.
Okay, great. So I suggest we keep the chat box open for another, let's say, 5 minutes.
Okay.
If any questions pop up. So Eric, big thanks from us.
You're welcome.
To you. And looking forward to future webinars. So also big thank you for all the people who joined this webinar, and looking forward to hear you guys again soon. Thank you.
Okay. See you next time. And bye-bye, and thanks for being here and your interest.